Hi there, I'm Hao, and this is just another video of me solving random code problems. So let's begin. So we need to find the sorted path with alternating color. You're given an integer n, the number of nodes in a directed graph, where the node are labeled from 0 to n minus 1. Each edge is red or blue in the graph, and there could be self edges and parallel edge, right? So it is a parallel edge, and then self edge is like this, right? Okay. Uh, so we are given the edge. Okay, A and B, so we mean A to B, right? So let's say we have like 0, 1, 1, 2, right? 1, 3, 1, 4, right? So this is the edge, right? If we write out, it will be something like this. 1 to 2, 1 to 2, and then 1 to 3, right? And then 1 to 4, right? So every time we need to process the neighbor, let's say we are at 1, right? Every time we have to process the 1 and then look at the neighbors at 1, we need to iterate through the edge, right, to find like the node that start with 1. It is not convenient, right? So usually whenever we are given like the edge, we should convert it into an adjacency list, right? So we can iterate like to this, we can let's say 0, it's 1, right? Look at 1, 1 is not in the graph, so we add it, right? 1 to 2, and then 1 is already in the graph, right? So we push it in here, right? Same for 4, right? So we can just like quickly look at the neighbors of 0 and 1, right? We need to return an array of answer of length n, where each answer x is the length of the sorted path from node 0 to node x, such that the edge color alternates along the path, or -1 if such path does not exist. Okay, so what does it mean? It means that like 0, 1, minus 1, right? So this is the index 0, 1, 2, right? So 0 to 0 is like 0 step, 0 to 1 is 1 step, and 0 to 2, right, is -1, because it's not possible. That's what that means. The x is this one, right? 0 to x. X is to be the index. Answer of x, right? This is the answer, right? And answer of x, which is so we want to find 0 to 0, right? 0 to x, so 0 to 0, 0 to 1, 0 to 2. Okay, so for we can just use a breadth first search for this, right? As soon as we found a node, then we know that it is a shorter path because we look at level by level, right? Um, in each step, each level just gonna be 1. Um, and so we can just have to run the breadth first search on every single node, right? And find the path from 0 to that node. Another thing we need to think about is that it is required that we need to alternate between the colors, right? So if I start from so let's look at the example right here. So we have 0 and 1, right? 0 and 1, 0 to 1, and then 1 to 2. Yeah, so there's only red edges. There's no let me just change the color here. So it is 0, it's 1, it's 2, right? So there's only the red edges, right? So the distance from 0 to 0 it is just 0, right? Because it's already 0, and 0 to 1 is just 1 level, and 0 to 2 is two level, right? Similarly, you can look at the second example. Uh, Oh, ac ac actually, 0 to 0 is 0, right? And 0 to 1 is one step. Even though 0 can get to 2, right, in 2 steps, but like it is expected the color to be alternating, right? So this has to be blue, but it is red, right? Because we look at the red edges here. So that is invalid, right? Um, if we look at the second example here, we have 0 to 1, which is the red edge, and we have 2 to 1, right? So 2 to 1, 2 to 1, which is the blue edge here, 2 to 1, right? So we can have 0 to 0, which is 0 step, right? 0 to 1 is 1 step, and then 0 cannot get to 2, right? Which is we have -1 here. So let's say, for example, this is not this is the blue edge instead. So we can get to 2, right? In two steps, right? That is valid. So because the color is alternating, so we can either go like red, blue, or blue and red, right? Which is also valid. So our starting point, right, will be, we need to keep track of the current color, right? Because like the next node we visit has to be the opposite color, right? So we can either start at red, right? Or we can start at like node 0. We always start at node 0, right? And then, or we can start at blue, right? So this is our two of our valid starting points. And we need to keep track of the visited node for the each set, right? Red and blue, to avoid infinite loop, because we have self edge, right? We have a cycle, like a node can reference itself, right? Um, yeah, so that's pretty much it. So let's put this up. So why don't we just start by converting the red and the blue edge into the adjacency list, right? Because we are given the edge, we need to convert it into the adjacency list. So for each, right, A and B, right, A1 and B1 like this, right? So what do we want to do? We want to put it in our, so if A is in the adjacency list of red, right? We can have an adjacency list here, which is an object. Right? So my strategy is that I can have like an object, which is like red and blue, right? Blue, like this. We can have like an adjacency list like this for red and for one, something like this. So that way I can just use like one single map instead of two. It's just a little bit cleaner. So if it is, if A is in the adjacency list of red, then we're just gonna keep pushing the element, right, into the array. So adjacency list of red, right, of A, of push B, right, and else we're gonna set the adjacency list of red of A equal to B, right? Same thing for the blue edge. Blue would be yes. If the starting point is in the hash map, then we just keep pushing the destination, right? The node that the neighbor, the node that it can reach. Otherwise, we just initialize the starting point with an array with one element. And we should probably also create some function. So red and blue, right, just equal to red and blue. Okay. And we also like need to initialize them with an object, right? Blue. Okay. So the red and the blue here, we start out as just like an empty object. Yeah, it's just another nested level. Okay. So we're gonna need what? We're gonna need a queue, right? Actually, we need to do the breadth first search for every single node. So let's do that first. So from 0 to n minus 1, right? This node, and then we need a queue, right? Equal to new queue, my queue. So I don't want to use an array as a queue here, and instead I will use my built-in sorry, my custom queue class, which will give us a shift of O of 1 if you use an array, right? Shifting will be O of n because we need to reassign the indices. Because there isn't a built-in queue class in JavaScript, so I just have to use my own. And feel free to use the built-in one if you use a different language like Python or Java. Right, and we need our visit depth, right? The key fact of the element we have visited, and it will be a new set, right? And actually, we can combine, right? We can do both for the red and the blue. New set for the red, and then new set for the blue. Okay, and y q dot length, we do something, right? And after that, we want to return our answer, I believe. So what is answer? We need to create our answer here, answer, right? Okay. So what do we want to do? So we already have the adjacency list here, right? Which means we can easily access the neighbors without iterating to the edge array. So our queue is empty now, right? Before we even enter the while loop, remember our starting point would be at 0, right? Because we want to find the closest distance, the shortest path from 0 to x, right? Which is to the node, to the node, right? 0 to node, right? So the node will be 0 here, the node will be 1, 2, right? Like this. So we need to have a starting point for our queue. And then remember that we can start from either the red color, the red edge, or the blue edge, right? That doesn't matter. So we want to enqueue 0, which is our start node here, right? Our color, we can just start with red, and then the distance, right? We need to keep track of the distance, right? Because the resulting array here, we need to return the distance from 0 to that node. And I probably should have a variable for them as well, a constant for them. So we're gonna do like star node, and then star this. Star node is 0, and star this is also be 0, right? So we can start from either color, either red or blue, like doesn't matter, right? And remember, because we start from the node 0, right? What does it mean? It's mean that we need to put it in our visited set, right? Star node, and then start node, right? So one for each. This one is for the red. This one is for the blue, because we start at like 0. So B0 is already in the set, in the visited set. Okay, so we can destructure here. We have the current node, right? The current node, the current color, and the current distance, right? Equal to q dot eq. Hello. Okay, yeah, sorry. Okay, so what do we want? What is our base case here? So we want to find the distance from 0 to the current node, right? Which is the node right here. So if the current node is equal to the node, right, then we are done. We want to do what? We want to break, right? Break out the while loop, and we want to push the distance into our answer array, right? So answer that push the current distance, right? And then what if we couldn't found the distance? So what if we couldn't found the target node from 0 to the target node? If such path doesn't exist, we want to push in -1, right, instead. Result of push -1 before we processing the next BFS, the next node, right? So how do we know that we found the path or not? So for example, right, if we look at node 0, which means our answer, right, need to be length 1, right? If we are at node 1, then we need our answer has to be of length 2, right? Right. If we um don't have, so if so because the node start at is 0 index, right? So at any point in time, after we finishing finding the path, then our answer length have to equal to the current node, right? Plus 1, right? If we are looking at node 0, then we need to have at least one. We need to have one element in our answer array, right? Which means we found a path. We look at 1, right? And it has to be 2. It has to be like 2 of like length 2. So if we couldn't found the target node, right, then we will never push the current distance into the answer array. So after the while loop, the answer will just be length 1, right? And we can check for that. So if the after we exit the while loop, if the answer like length is less than node plus 1, right? Then we will push in the -1, which means we couldn't found the target node. Okay, that makes sense. So every iteration, the answer array have to increase the length by 1. If it is not, then it means we couldn't find the target node. We should push in -1 here. Okay, so that is our base case. So we need to keep iterating, right? Keep looking at the neighbors of the current node, right? And we need to alternating the color, right? So we need to find our next color. So what is our next color? We can use our current color here. So next color equal to current color. If the current color equal to red, right, we return blue. Otherwise, we return red. We can put it here, right? And we need to look at the neighbor as well, right? What is the neighbor? The neighbor will just be the next color, right? So adjacent list of next color, yep, and the current node, right? So it is two-level D, right? The first one is to find which adjacency list we are looking at, the red or the blue, and then we're gonna find the neighbors by passing in the current node. Okay, so we have to so if we have neighbors, right? Because the neighbor can be unified, right? If the current node, the key is not in the map, right? So if we have the neighbors, then we want to iterate into the neighbor. So we have the next node here. and we want to do something with it. Right? We want to push it into our queue, right? Queue dot enqueue. We need the next node, right? The next column, and then the current distance, right? Plus one. Because it is the next level, so we need to increase by one. What else do we want to do? Remember that we need to keep track of the visited node, right? So we don't want to process the neighbor if the neighbor is already in the visited set, right? So if visited doesn't have visited of next color, right? Not as the next node, then we want to process it, right? By pushing it into the queue, then we need to mark it as visited. So visited of next color of the next node, dot add next node, right? And I believe that's pretty much it. Okay, so let's recap here. We start out by converting the edge to the adjacency list of red and blue, right? We need to run the breadth first search for each node, right? So that is the for loop here. So inside the for loop, we need to do BFF. So we have a queue, right? And we have our visitor set to avoid the infinite loop, right? And we can start out by the starting node, which is always be zero, because we want to find the shortest path from zero to the node, right? The current node. And the edge color has to be alternating, so we can start out either red or blue, and the start distance will be zero because that is our target results, right? So YQ dot length, we DQ, right? We find the next color, and we look at the neighbors. So if the current node is equal to the node, right, which means we found our target, so we push in the current distance, and we break out of the while loop, and then continue on to the next node, right? And if we when we break out the while loop, and the answer length is not increasing at all, then we will push in -1, which means the target node is not found, right? So that is our base case. For our recursive case, our recursive step, what do? We find the next color and the neighbors, right? So if the neighbor exists, then we iterate to each and every single neighbors, right? If the neighbor has not been visited, then we push it in our queue, right? We increase the distance by one, and we push in the next node and the next color here because we want the color to be alternating. And then we just mark it at visited. Okay, so let's give it a try. Result dot push. It should be answer, right? Okay. And thank you for watching.